In this next set of 3 videos, we're going to make a MIDI effect that sequences incoming notes with user-specified velocity values and is synced to live transport. In this first video, we're going to work on the MIDI part of this device. Load a default Max for Live MIDI effect into a MIDI channel in front of a synth and open it for editing. Arrange it on your screen so that we have some room for adding code. We'll keep the MIDI through cabling for now. This part of the device does our MIDI analysis. We need to know if a note or notes are being played and what those notes are. To do this, we're going to use a bunch of old school Max MIDI analysis tricks. First, let's organize our incoming MIDI stream. The MIDI pass object splits up a MIDI stream into various types. Create a MIDI pass object and connect the MIDI in object to the MIDI pass object's inlet. Add a message box under it, and let's hook up the first outlet of the MIDI pass object to the right inlet of the message box so that we can see the messages that are sent. The first outlet of the MIDI pass object outputs the current note velocity pair as a list. Play a few notes on your keyboard and you can see the note number and velocity value displayed in the message box as a list. A really useful piece of MIDI analysis information is the number of keys currently held down. To find this out, we can use the Borax object. The Borax object takes a note value input and a velocity input. To split these numbers out from the MIDI pass output, we'll use the unjoin object. The third outlet of the Borax object reports the number of notes being played. Hook up a message box to this outlet and play some notes on your keyboard. You can see now that we know how many notes are being played at any given time. So now we know how many notes are being played. The next part will tell us what these notes are. We're going to need another copy of the note data from the MIDI pass object. To get this, we'll put a trigger object after the MIDI pass object and give it a toList argument. The shorthand for this is TLL. The trigger object takes a list input and copies it out to the rightmost outlet, then copies the same list out to the leftmost outlet. Now we're going to use another Max object, the bag object. The bag object manages MIDI notes for us. It holds on to notes with velocity values greater than 0 and discards notes with velocity equal to 0. When you bang the bag object, it sends its current notes out in sequence. When the number of notes being played changes, we want the bag to output, telling us what the currently played notes are. We know when a number of notes changes because the Borax object outputs changes. So let's use the change to drive the output of the bag object. Connect the outlet of the Borax object to a trigger object. Let's create a trigger object and type TBI. The B outlet goes to the bag object and tells it, when the number of held notes changes, output all the current notes which are playing. The I, or integer outlet of the trigger object, goes to a ZL group space 1 object. This outlet tells the ZL group object how many notes to join together into a list. Once the ZL group object has received the number of notes it is looking for, it will automatically output them as a list. We can see this if we add a message box under the ZL group object. Let's play a couple of notes on our keyboard. You can see that we're getting a list of currently played notes to display in the message box. But there is a problem. When no notes are being played, we can still see a note present in the message box. So we need a way to clear the values out of the message box when the number of notes being played equals 0. Hook up a select 0 to the output of the Borax. This object will send out a bang when there are no notes being played. We can use this bang to send the set message with no argument to the message box to clear it. So now we have a list of note values for all of the currently playing notes.